we are going to review how to use trig ratios to solve for a side length. For any acute angle between 0 and 90, say angle A, so that's this angle down here, in a right triangle, there are three trig ratios. They are sine, cosine, and tangent. Before we state the ratios for angle A, what we should do is label our diagram. So remember that across vertex A, or angle A, is side A, across vertex B is side B, and across the right angle is side C. Always start by identifying the hypotenuse. Remember, the hypotenuse is across the 90-degree angle. Next, for the sine ratio, for example, we need the side opposite angle A and the hypotenuse for the ratio. Well, the side that's opposite angle A we know is side A. So side opposite angle A is right here. This is opposite angle A. So for our sine ratio, it is the side opposite angle A, which is side A, divided by the hypotenuse, which is C. So the sine ratio is just A divided by C. The cosine ratio requires that you decide adjacent to angle A. Since we've already identified side A is opposite to angle A and C is the hypotenuse, then B must be the adjacent side. So B is adjacent to angle A. And adjacent just means right beside. Notice the hypotenuse and the adjacent side are right beside angle A, but the hypotenuse already has a name attached to it. So if we want to find the cosine ratio, it's the side adjacent to angle A over the hypotenuse. And if we look at our triangle, the side adjacent is B and the hypotenuse is C. And finally, we have the tangent ratio, which we take the side opposite to angle A and divide it by the side adjacent to angle A. So in our picture, the side opposite to A is A over the side adjacent to A, which is B. So these would be the sides that you would compare in order to find the following trig ratios. If we are focused on angle B, so here's angle B here, the sides would still have the same labels in terms of B, A, and C, and the hypotenuse will still be called the hypotenuse. However, if we're focused on angle B, so side B is now what we call our opposite side. So it's opposite angle B. And side A becomes our adjacent side. So side A is adjacent to angle B, which changes our ratios. So if I wanted the sine of angle B, that would be the side opposite B over the hypotenuse. So that would be B over C. The cosine would now be A over C, the adjacent to angle B over the hypotenuse, and the tangent will become B over A. So depending on which of the non-right angles you look at, that'll dictate, or that'll decide what your ratio will look like. So it's either going to be this angle or this angle. We don't worry about the 90-degree angle. Let's see how this helps us find side lengths. So determine the indicated side length. The first thing we're going to do is label our diagram. The second thing we're going to do is state an equation. And for us, that's going to be sine, cosine, or tan. So this time we have to pick which one will work. And then we can solve. So let's start by labeling. So let's call this side A, this side B, and this side C. So the 52 centimeters is our hypotenuse, which is side C. The side that we're looking for, X, that's our side B. So to decide on an equation, we need to look at the angle we're focused on. We're focused on this angle here, the 35 degrees. So let's label the sides accordingly. So let's start with C. We already know is the hypotenuse. And we know that side B is opposite that angle that we're focused on. It's opposite angle B, because that's our angle of focus. So what we do now is we look for a ratio that has opposite and hypotenuse attached to it, because we need the opposite side, because that's what we're solving for. We need the hypotenuse, because that is the only side we have information for. And if we look at our ratios, the one we should pick is sine. So sine of angle B, if we look at our triangle, the side opposite angle B is B, and the hypotenuse is C. So there is the equation we're going to use. Next, we sub in our values. So we have sine of 35 degrees is equal to x, that's side B, over 52, that's side C. Next step is to get x by itself. Right now we have x divided by 52, so the opposite operation is to multiply both sides by 52. Because 52 divided by 52 equals 1, so we want to get 1x. What is 1x equal to? So if we do that, we get x is equal to 52 sine 35. So the last part is to now use our calculator. So on your calculator, you can type in 52, find your sine button, type in 35, and hit enter. And if your calculator is in the right mode and you've hit the right button, you should end up with 29.8 centimeters as your x value. If you did not get 29.8, it could be one of two problems. The first problem is your calculator needs to be in degree mode. On your calculator screen, you should see a DEG, or you should see a little d there. If you see those, then you're in the right mode. If you see rad or r, or if you see grad or g, you're in the wrong mode. If you're in the wrong mode, you need to change it to degree mode. If you need help, please contact me and I'll try my best to help you get it into the right mode. Second thing, depending on your calculator, if you have a display calculator, you would just type exactly what you'd see. You type in the number 5, you type in 2, find your button, that's sine or sin, the button 3, the button 5, and then you hit your equal sign or enter, depending on your calculator. Some calculators work backwards, and you might have to type in 52 times 35 sine and equals. So that depends on your calculator. Again, if you're having troubles, you need to contact me right away so we can figure that out. So let's try this again. So here's our angle of focus, 65 degrees. Let's label our diagram. So A, B, and C. So if you like to keep your right angle as C, that's great. This time we have H here. So H will be our A. B is going to be 38 feet. And now let's discuss what we have. Relative to 65 degrees, this is opposite angle A. So we're focused on angle A. So what is 38 feet? It's right beside angle A, so that's called adjacent angle A. And we know it's not the hypotenuse because the hypotenuse is right here. It is opposite the right angle. So we have adjacent and opposite. The opposites are unknown. The adjacent is our 38 feet. So we need to pick a ratio that is opposite and adjacent. And if we look at our ratios, that would be our tan ratio. Tan of A is equal to the opposite side, so that's A, over the adjacent side, so that is B. Next, we sub in our values. So we have tan of 65 is equal to H, that's our A, and our B is 38 feet. Same as before, we have h divided by 38, so the opposite operation is to multiply by 38. And that gives us that h is equal to 38 tan of 65, because this 38 is gone. 38 divided by 38 is 1. And using our calculator again, we do 38 tan of 65, and we end up with 81.5. So therefore, h is approximately equal to 81.5, and our units in this example are feet. Last example. So this one has two twists to it. So let's go through this one. First of all, let's label. So A, B, and C. So there's our hypotenuse, there's side A, and there is side B. Our angle of focus this time is 70 degrees. So side B is actually adjacent. It's right beside angle A. And that's the only angle that we know at the moment. And C, the side we're looking for, or D, is the hypotenuse. So we want a ratio that has adjacent and hypotenuse. But even before that, we have 2 feet 3 inches. We should convert this. So remember that 1 foot is equivalent to 12 inches. So that means that 2 feet is 24 inches. And 2 feet plus 3 inches is equal to 24 plus 3 is 27 inches. So we're going to use this as our value for B. All right, next thing is to pick a ratio. So we have hypotenuse and adjacent. So the only ratio that works for that is cosine. So we have cosine of angle A, that's our angle of focus, is equal to B over C. Next step is to sub in our values. So we have cosine of 70 degrees is equal to, well, we see that side B is 27 inches. We converted that. And this time we have D in the denominator. So the way to fix that problem is, because we can't solve it within the denominator, we have to get the D into the numerator. And what you may know is that cosine 70 as a fraction is cosine 70 over 1. What I'm going to do is I'm going to flip both sides of the equation. For example, I know that 1 over 2 is equal to 2 over 4. If I flip that equation, 2 over 1 is the same as 4 over 2. So flipping the equation, that the equal sign is still valid. 1/2 equals 2 over 4. That's 1/2. 2 over 1 is equal to 4 over 2. So let's use that concept. I can now say that 1 over cosine of 70 is equal to D over 27. And we only do this when the variable, right here, that we're looking for is in the denominator. Okay. To get the D by itself, it's D divided by 27, so I'm going to multiply both sides by 27. And when I do so, I end up with, these cancel, D is equal to 27 over cosine of 70. And if you're unsure why that is, remember this is 27 over 1. We multiply numerator with numerator, so 27 times 1 is 27. We multiply denominator with denominator. 1 times cos 70 is cos 70. The last part is just to use your calculator. So 27 divided by cosine of 70. And if we've done this all right, we end up with 78.9 inches. If your answer for D was smaller than 27 inches, then you know you made a mistake, because remember the hypotenuse is the longest side, and clearly 78.9 is larger than 27. Here are some questions you can try out. Again, if you have any questions, please contact me right away.